maybe turn off video just for a better bandwidth, like that will help me. Yeah. So just to start, so I'm Kuldeep Kumar. Currently, I'm doing a postdoc at Saint Justine Research Center in Montreal. I did my PhD, which was in computer science and neuroscience from ETS in University of Quebec in Montreal. Prior to that, like I had my bachelor's and master's from IIT Kharagpur, and I was working as a scientist in Indian Space Research Organization, where I was able to also work on like Mars orbiter mission. Like we had like 3 payloads, and that was a nice mission from India. So other two instructors like with me would be Praveen. So he is also a researcher at University of Quebec. He did his master's from IIT Guwahati, and he was a senior software engineer at Samsung Research. And Naresh, so he did his master's from Indian Institute of Science in Bangalore, and he was lead Samsung research at India, and also right now he is like senior tech lead at BMW Germany. We also have like a parallel course which is going on, so like we are the three instructors which will be taking care of. So the overall goal here is to give you a brief idea like what would be the motivations and all, and then to provide like what you are going to learn in this, and along with that a detailed course description like what is and how this is going to be slightly different from other online courses or like what we have to offer to you. So I will just start with a basic like introduction. So for example, so what is different for machine learning compared to traditional programming? So what used to happen like in giving a very broad overview. So in case of a traditional programming, you will have data and you will and then you feed it as well as you write your program and you will get an output. So, for example, if I'm going to ask you, like, have you played chess? Like, any one of you, have you played chess? Um, okay. So it's like if I am to ask you to write a program for, say, chess, what you will do is like you will figure out some set of rules and then you will try to like, okay, you have to follow these rules and you will write some heuristics. If I start with this and that, so there would be like a lot of permutations and combinations. So that can work like if you have like two or three choices. For example, you go for a shopping, okay, I have to buy a chess board. There it's fine, like okay, there are three options, I can decide like what. But when there are like the permutations, they go on and the complexity increases, then it becomes intraceable, like and the computational power is increasing. So there comes like machine learning, where the goal shifts from like instead of like relying more on heuristics, what we rely is like we rely on the data more. So here the story is like you feed the data as well as a set of labels or the outputs to the computer, and what it will try to give you is like a program. So what it means is like based on the data, it's going to learn like what should be the output. To give you an example again on the chess, so have you heard about the Alpha Go and Alpha Zero? Like any one of you? So, okay, so this is like essentially in 1997, the Deep Blue, which was like a supercomputer. So this is like a brief story kind of thing. So in 1997, there was a competition between Gary Kasparov. He's like a champion in chess, world champion in chess, and the Deep Blue, which was like a supercomputer from IBM. So in the 6 games, he was beaten, but that program was more like the what are the possible permutations and combinations. So recently, like over the last couple of years, like Google's DeepMind, they have developed some programs, including for example the alpha zero. So here what they do is like they feed lot of simulations of the chess program, and the program itself learns the strategy. So what the difference arises is like some of the paths or some of the strategies which we as a human are not able to think, those would also be figured out by this, and it took like just 4 hours to learn. So this is just to highlight you like what is the difference between a traditional programming and machine learning. It's just like we shift from more like heuristic based approach to more like a data driven approach. We let the data do the talking. So now I will like give you a brief overview like how this has come over. So have you heard about the Turing Award of 2019? So I guess like you might follow on that. So the three of the pioneers in deep learning, for example, Yoshua Bengio, Geoffrey Hinton, and Yann LeCun, they got the 2019 Turing Award, which is like a Nobel Prize equivalent in computer science. So this is like a brief history of the AI. So it started in like 1956 when there was like a workshop in Dartmouth College in USA, where a set of researchers they get together and they officially started artificial intelligence as a research in academic domain. So then there was like a inspiration, like the perceptron was introduced in 1958, which takes motivation from how our brain works. So what it tries to do is like the perceptron, it tries to mimic how a neuron is processing the information, so which is like a building block of our brain. So this is like a motivation for the AI is like how we as a human we work or we process information. For example, even now when I'm speaking to you, so I am like formulating my sentences, I'm trying to like, okay, whom I am interacting with, what is the topic, what I have to convey and all. So I'm processing a lot of inputs which could be sensory and all, and then I'm giving output. And you are like, when you are listening to me, so your brain is processing, okay, what is being told, what are the words and all that. So this is like the basis of like, or the basic motivation towards most of the AI is like driven by the human brain. There have been like a lot of advances in between, like for example the perceptron was there, but in between there were like computational challenges. We didn't have like hardware or the computers which could solve all those programs. So what then it led to an AI winter. So there was no fundings like available for like a long period of time. But then around 2000, then there was like with the development of the new hardware and like different lot of data sets, for example, from Google or like Flickr, Facebook, and all those things, then there has been a burst. So this is like a rough timeline. It started with like a lot and lot of hard work from many of the researchers, and the recent thing is like it is highlighted by the Turing Award, which was given to three of the pioneers of AI. So next is like the question which will come to us is like, so we hear a lot about these words like, okay, so what is deep learning? There is machine learning, and then there is artificial intelligence. So it's always like thrown like one word and now another word. So nowadays, mostly like even for deep learning people, they try to use like, okay, it's artificial intelligence also. So just to like give a broad idea about this terminology. So artificial intelligence, the goal is like any machine which can perform like an intelligent task. It can be our calculator, it can be a simple robot, or it can be like a simple like answering machine. So this is like a broader umbrella. So under this like comes a specific set of like machine learning, so which are like set of algorithms where the goal is to represent the data and extract information from that which could be relevant. So there are different kind of models which are there, and within this like there is a subset which is like a deep learning which are kind of like a set of models like convolutional neural networks or like Turing machine and LSTM and different models which have been developed over the past year. So this is a broader picture. Now the thing which comes out is like, so what is the motivation like? What are the applications of machine learning? Why there is so much hype which is going on? So I will ask, like, do you have like an email account? So everyone has like multiple email accounts, I guess so. So for example, there like with a rough estimate, there are more than 5 billion email accounts are there. And so as such, like the number of emails which are being sent day in, day out is in the scale of billions. Now imagine like you are working, and or if a person he's going to get an email from a prince in Nigeria who is like going to send me the gold. So we know this, okay, there is no prince in Nigeria who's going to send me gold. So we know that this is a spam. But imagine like you are going to get something from Canada Revenue Agency, like a phishing site. So you can either lose your sensitive information, or you can lose like some part of like for example, some people who get scammed and they lose a lot of money. So this is a very important thing for many of the organizations to detect such kind of emails, which are called spam, from the regular emails. So what is the basic way you, what would be the basic intuition you will have to like detect a spam? So if I can ask any one of you. So,
Anyone? Harish?
Yes.
so
Yeah. Yeah. It could be
so
like
yeah, yeah, go ahead.
uh, for a spam, like, so as you mentioned, some phishing emails. So that could be like grab our information, right? To get our information.
Yes.
Um, but maybe like, so based on the keywords in the subject or in the content of the email. So based on that, I believe that so they're gonna do so they're gonna filter all our emails. So based on the keywords. So if they find the keyword, so they're gonna put uh, the emails into the spam folder.
Yeah.
Is that
Yeah, yeah, perfectly. So that's like one of the things. So here, what we are employing is like our knowledge. Like, okay, if there is a prince from Nigeria, I know for sure, like he's not going to be like true, or like if the subject is something like, okay, I'm going to send you gold, or like the contents are like that, then we know that this is a phishing. So what we are employing here is like our knowledge. But imagine like you have to do it like for billions of emails. So then you cannot just rely on the knowledge and all. So what usually they try to the approach for this is like, we think of it as like a data driven approach. We'll take a lot of spams, and then based on the information and content from the sender, the IP address, all this information, so that's kind of like fed into a model, and that tries to determine which email is spam or not. But the objective, like when the advantage of machine learning here is like it is able to generalize. So it not only learns on the data on which you are going to feed, but what it will try to do is also it will try to learn a model, so that when the new data is also coming, it will be performing robustly. Whereas like if we just employ our knowledge, okay, this is a prince from Nigeria, then that would be restricted to those kind of scenarios. So this is like one of the cases. Another example is like, for example, if I'm going to search on Google, if I'm going to search, so what do you want? Like, what would be your preference? You would want like what is most likely link you want to click. If you are going to search for the weather outside, you don't want to get an information about weather in Toronto. You want, if you're searching for weather in Montreal, you want to get information specific to that, or like if there are warnings specific to that. So this is like essentially ranking the output of the web pages based on what you want. Another example of this is essentially if you are want to do a shopping, like if you are doing e-commerce. I guess like most of you have used like shopping pages and all, and then you get thrown a lot of advertisements. So have you had like any recent transactions or interactions on online shopping platform? So
yeah,
so
Kumar? Like, so for example, when I search in a Google for some product, so it's going to appear on my Amazon account. So is this something related to this, right? I
yeah.
think. Okay. Uh, yeah. Nice.
Okay. So for example, like in this, so what happens is like, imagine you want to book a flight, and you make a search on your Google page about the flight. Then even if you go to a weather page, you will be seeing that there are like pop-ups which are like based on your flight, which are going to come over there. So this is essentially like ranking the page based on your search, as well as like content placement, like advertisement and all. So it is customized to a particular user. So if I'm going to ask you as a friend, like, okay, what you want to do, so I know your preferences and I can suggest you based on that. But if the Google, or like for example Facebook, or any general search engine or a site, it has to suggest, so it has to customize or tailor made to specific people. So this is another thing, like where the content base or the web page ranking and the content or the advertisements are like important. So this is like another example of, where machine learning is useful. So for the third one, for example, this one. So have you heard about the autonomous driving, like, or Tesla, like anyone of you, like, for example? So for example, so this is like a very good example of application of machine learning. So when we are driving a car, so we are taking the information from the environment, like, okay, what is the color of the light? Should I go or should I not? What is the speed limit? What are the things which which side of the road I should drive if there is a passenger which is coming? So this is essentially like processing a lot of information. So now, for example, for autonomous driving, so these informations, these are fed into or captured using cameras, and then based on that, instantaneous decisions are taken which can lead to driving. So this is going to like leading to self-driving cars, and also like for example BMW, and they are exploring. So yeah, can I like, okay, I got like a question. Yeah, so just a minute. Like I had like a question maybe in terms of the chat. No. Like search for Apple in Google search engine, you can get Apple products. So this is like from Celine. Aravind, so this is like search for Apple in Google search engine. You can get Apple products rather than the fruit apple. This is based on ranking, right? Yeah, exactly. So if you are going to search like, so imagine first time if you search like apple or fruits and you go on customizing that, then the higher chances would be to get the apple fruit. But most of the people, I don't think they are going to search for apple fruit. So when you search for the Apple products, they get customized. So even the advertisement which will pop out on another pages, they would be like specific to the Apple products, like that. So now coming back to the self-driving car. So in this case, like what is happening is like you have to take a lot of information, process it, and take an instantaneous decision. So if we as a human do it because we have our brain, which is like processing all this information. But for a self-driving car, or for example, a self-driving truck, this would have like, this requires like a lot of processing power and all. And this is where machine learning comes into picture. If we try to write a rule, we may miss one thing or another. Okay, the driving speed may be missed, or like if the road condition is going to change, we may miss it. But if we try to feed it like based on the data, then they are going to perform better. So this is like an image of the DARPA challenge, which is like the Defense Department of US. Like they have been organizing a challenge since 2000, early 2000s, and they this has led to a very nice developments, like which is like an example is the Tesla, like the recent products from Tesla, or like the self-driving trucks from BMW and on. So these are the few examples where like a traditional like approach or would not fare that well, whereas like if we are employing a machine learning approach, that is going to work better. There are multiple examples also. So for example, Alexa, if you are using Siri, or like Google Home, or any of these products, or if like for example you are like in a financial company and you want to know like which people you want to send a specific credit card offer. So you don't want to send it to everyone. You want to send it to the people based on their incomes. Okay, this particular credit card would be suited to them. And so these are the tailored things. Similarly, for example, in e-commerce, you have a lot of transactions which are going on. So you want to detect whether there is a transaction which is fraud or is it genuine, so that you can like keep the safe security as well as like of the e-commerce platform. So this is like to give like some of the aspects which are like why machine learning is like getting popular and like it is going on now. So then the next thing is like why machine learning now. So this is like, so there recently there has been a report, like if you like by McKinsey, so which is like a consulting firm. So they did an analysis on the potential of AI and what are going to be its impact. So it is going to impact many diverse fields, but the estimated like overall contribution to GDP is estimated to be like $13 trillion by 2030, which is like a huge amount like of the world GDP. So the question then arises is like, why now? So I'm going to ask, like, for example, Aravind, so you use Facebook, right? Hello. Hi, Aravind. So, so we use like, for example, Facebook or like YouTube, we watch like every day. So when we upload like anything on Facebook or when we click on anything on Facebook, so what it does is like it creates a data point. Like we are telling the Facebook, okay, this is my preference. This is the type of things we like. So these are like data points. Now there are like billions of interactions happening like that every day. Similarly on YouTube, like there are 100 hours of video being uploaded every minute. If a single person he starts watching a YouTube video today, he cannot finish all the YouTube videos in his lifetime. So there is like huge amount of data which is getting generated. So this is like the one pillar of this thing, which is like big data availability. So we have like a lot of data to learn from. Then the second thing is like the computational power. The second pillar is the computational power. So we used to have like the CPUs, which were like the brain, the computational power used to be more driven by that. But now we are also getting like the powerful graphical processing units. So the slight difference is essentially a graphical processing unit has like it's a specific type of microprocessor which can deal with like a large parallel task, but can only focus on one task at a time. What it does is like imagine you want to do one specific task, so then it will give you a power to do it like 10 times or even 50 or 100 times faster than with the CPU. So these things, they allow us to deal with the big data which is there. Then the third thing or the third pillar is like the new machine learning techniques which are coming up. So every day, like either we hear like there are neural networks like AlphaGo is being developed, or like we are beating we are developing new methods which can like play better chess, or like a player in Go. Or even like if you follow the news, like recently there was like on the black hole image which was reconstructed. So we had like huge amounts of petabytes of data, and then to learn the prior, the machine learning algorithm was used. So it was and based on that, then the final black hole image which was being constructed. So these are just to give you an idea, like what are the three pillars which is driving right now. So some of the aspects were there before, like for example, some of the concepts in terms of machine learning techniques, they started in 1950s, but then the two other pillars were not there. But right now is a time when we have like all the three pillars, like there is big data which is available, there is like the computational power which is available, and then we have like the new machine learning techniques which can infer, like which can take this data as an input, or a simplified term which can feed on this data. So just to give an example, like if you have like an image, like imagine you take a photo and you want to process it to name it, like okay, what is going to be there and all. So it's going to take around like 250 seconds on CPU, but with the GPU it's going to be like around like 1/10 of the timing. So these are the advances which we are getting. To give you a better idea, for example, so there is like an ImageNet challenge which is there. So what is ImageNet challenge is like, we want to recognize images or we want to classify them. into say 1,000 categories. So this is like, for example, I will give you an example of a baby or like a kid. When we teach a kid, like, okay, this is a cat or this is a dog, we give one or two examples, and after that, a baby can recognize this is a cat or this is a dog. This is how like we learn, how our brain is learning. But for the computer, we need to feed it like a lot of samples. So for this, like the ImageNet challenge was created where 1.2 million training images, they were taken from Flickr, which was like an online platform for images and all, and they were annotated to 1,000 categories. So like what it is there, like there is a bird, there is a frog. So this challenge was going on from 2010 and all. So in 2012, there was like a sudden jump, like from at the error rate, like it was like 26% to it jumped to 16% because that was a time when Google Net was used. So this is like a deep learning architecture. And recently, like in 2017, we got an error rate of 3%, which it means like if the machine is going to classify the images like, okay, it's a bird or a frog, it's only going to like get a 3% error rate, whereas in 97 cases it's going to be perfectly fine. And this is better than the human error rate. We have like a 95% accuracy when we are doing this. So it means like, is it over? No, there are like multiple things are still there. So for example, like what we want to do is like, we want to understand the whole image, like what is the background, what is there. So as a kid, like he understands the context also, like as a kid without teaching, like if he's going to fall down from one place, he's not going to climb that same place second time. He understands that context and all. So this is called scene understanding, which is still going on. So this is just to give an example of like what is the potential of ML. So now to come to a point like which is like more useful to you and me, like why we should learn like machine learning right now. So if we go to any of the job postings, so we are going to see like there are machine learning job postings, data scientists, and like AI, and then there is like 50% expected job growth which is going to be there, and the average salary is like at least 100,000 and plus. Even like in Canada, so this is like the estimates of machine learning jobs in Ontario and overall Canada, it's going to be like huge. And for example, Montreal itself, like to give you an example, Montreal and Toronto, they are going to be the hubs for these things. So this is like an opportunity, like the optimal time where the resources are there, where the demand is there. So what is there is lacking is like the skill, which is like, that's why we try to focus on the skill, like what is required to for this. So now to give you an idea, like, so for this particular course, what we are going to cover, like this is like a big picture. So the focus would be like, we will try to cover the fundamental concepts of machine learning, but our primary focus would be on hands-on experiences. So what we will try to do is like, we will have a lecture usually, then the next class would be a tutorial, and then we will give you a small data set to try it hands-on. So the primary focus is like to introduce you to the concepts, and as well as like focus more on the hands-on. So for this, like we will be using Python primarily, and then we will also like try to do the other major goal would be a real-time project. So we will towards the end, like we will go for a real-time project. So for this, like either you can look into some Kaggle challenges which are there. Imagine you have to predict the property prices in certain area. So that's like one of the projects which is there. Or if you have to like estimate like in terms of the insurance. So these are like the in terms of the business or the topics which are coming nowadays. So this is like a broader picture. So if you have any questions, like you can ask me or like later on. I can also give like, so to give you a broader, like a more detailed idea of like what the course is going to cover. So we are going to give you an overall introduction of like what are the different types of learning or like approaches are there. Then within this, like what are the classification techniques, each one of them. So for example, we will cover support vector machine, random forest, and for each one of them we will have like a concepts class, then we will have a hands-on tutorial, and then we will give you like a small data set to try that on your own so that you gain expertise. And in between we will have quizzes so that we can like get whole like, okay, if you are learning or not. So next we will also cover like the regression techniques, the clustering when which is unsupervised, and also like some deep learning techniques with application to deep learning. So this will also like what the base this will also require some like concepts from linear algebra like maths and all calculus. So we will have like some of the basic courses on this like prerequisite courses. So we will try to cover these basic concepts, and then the key thing will also be like to focus on data, like if you get a raw data, how you are going to process it, how you are going to feature engineer, like what features you need to use, and what are the basic approaches you can apply. So so this will also lead you to like hands-on experience on various libraries from Python, including NumPy, Scapy, and sklearn, Pandas, and Matplotlib, as well as like a real-time project.
Kumar, I have a question here.
Yeah, yeah,
Uh,
sure.
so for example, like if I'm like a beginner to the Python, or actually like if I don't have the programming knowledge, so how difficult is to get into the machine learning?
So like if you have like basic programming only, like if you can know like, okay, what if you can type and have basic information on that, then it can be started. Like the Python is very easy. So the hands-on tutorials which we will be doing, we will start with like how to install some of the libraries, how to use them, and we will also give some use cases. So that will develop like this is like the Python hands-on. So you will also develop like the expertise on Python and how to use these libraries.
Okay, okay, that's awesome. Yeah, cool. Thank you.
So for the next, like what we plan to start with is like in terms of the supervised learning, we will start with the background, motivation, what are the real-time applications, definition, and list of algorithms. So this is just like a overall idea. And so if you have any questions, please